Good morning, it's March 11th, and this is your daily brief in science. Here's everything you need to know. Mark your calendars for April 8th, 2024, as the sky presents a celestial spectacle not to be missed, a rare super new moon eclipse. This extraordinary event will grace the skies over the Pacific Ocean, Mexico, the United States, parts of the United Kingdom, and Canada, offering a unique viewing experience to millions. The mechanics of this eclipse reveal a slight off-center alignment, with the moon appearing 5.66% larger than the sun. This configuration will allow for a total eclipse phase lasting up to 4 minutes and 28 seconds at its peak. This phenomenon is part of the Saros series 139, a sequence of eclipses that will see its peak duration in the year 2186, showcasing the long-term cycle of these celestial events. Amidst the awe of the eclipse, a concerted effort from the scientific community will turn this event into a vast field study. Projects like Eclipse Soundscapes, GLOBE Observer, and student-led balloon launches aim to capture data on temperature, cloud cover, atmospheric gravity waves, and the ionosphere. Additionally, amateur radio operators will join the HAM-SC1 project, attempting to make contacts during the eclipse's totality to study its effects on the ionosphere. In the midst of a global health crisis, 2 recent studies shed light on the profound impacts of the COVID-19 pandemic on both the treatment of chronic diseases and the ethical dilemmas faced in hospitals. These findings not only reveal a stark increase in mortality rates for certain patients, but also expose the complex moral quandaries that healthcare professionals navigate daily. A study published in Scientific Reports has brought to attention the significant rise in in-hospital mortality rates for patients suffering from acute exacerbation of chronic obstructive pulmonary disease, COPD, during the pandemic. Interestingly, while the mortality rate surged, the actual number of hospitalizations for COPD patients saw a decline. This paradox suggests a shift in healthcare dynamics during the pandemic, with potentially severe implications for patients with chronic conditions. Another study addresses the ethical dilemmas doctors face in allocating limited medical resources like ventilators in ICUs, with a tendency to prioritize younger, healthier, and socially valuable individuals. These studies highlight the urgent need for comprehensive healthcare plans, enhanced pandemic preparedness, and robust ethical guidelines. They underscore the importance of addressing both the direct effects of pandemics on patient care and the underlying ethical considerations that can profoundly impact decision-making in crisis situations. As the world continues to navigate the complexities of healthcare in the face of unprecedented challenges, these findings offer crucial insights into improving support for individuals with chronic illnesses during a pandemic. In a groundbreaking study, researchers from the University of Oxford have cast a new light on the profound impact of climate change on marine life, hinting at the alarming potential for a 6th mass extinction. Delving into the fossil records of over 290,000 marine invertebrates, the study spans an impressive 485 million years, providing a comprehensive look at the resilience and vulnerability of life under the sea. The research, published in Science, specifically zeroes in on species with small geographic ranges and limited ability to adapt to temperature changes, such as snails and shellfish. These organisms, the study finds, are at a significantly higher risk of extinction, especially when faced with local climate changes of 7 degrees Celsius or more. The implications of these findings are stark, underscoring the urgent need for conservation efforts and further research to prevent a potential 6th mass extinction driven by climate change. The call to action is clear. Humanity must prioritize and expand conservation efforts to safeguard our planet's biodiversity against the looming threat of climate change. In a stunning leap forward, AI at Stanford University has outpaced centuries of human research in a matter of weeks, uncovering the existence of rare kidney cells known as Norn cells. This remarkable discovery not only showcases the power of artificial intelligence, but also ignites a conversation about the future of scientific exploration and discovery. The AI models, named Gene Former and Universal Cell Embedding, were not just programmed with existing biological knowledge, they were designed to learn biology from scratch. By analyzing raw data on millions of real cells and their genetic makeups, these models taught themselves to identify and understand the behavior of genes in various cells, achieving what took human researchers 134 years in a mere 6 weeks. This approach has not only led to the discovery of Norn cells, but also to a deeper understanding of developmental biology. The implications of this discovery are profound. It challenges the traditional role of human biologists and suggests a future where AI could lead the way in scientific discoveries, offering insights that might take humans decades or even centuries to uncover. Yet, it also raises critical questions about the balance between technological advancement and ethical responsibility in the quest for knowledge. In a groundbreaking stride towards combating cancer, a recent study has unveiled a novel nanoplatform that marries the power of photodynamic therapy, chemodynamic therapy, photothermal therapy, and chemotherapy into a single, potent treatment method. This innovation leverages mesoporous Fe3O4 at TiO2 microspheres, capable of generating reactive oxygen species for photodynamic therapy, catalyzing the decomposition of H2O2 to produce oxygen and cytotoxic hydroxyl radicals for chemodynamic therapy, inducing photothermal hyperthermia, and efficiently releasing the chemotherapy drug DOX. A remarkable feature of this nanoplatform is its high biocompatibility and the ability to be magnetically targeted directly to tumor sites, promising a new horizon in cancer therapy. Published in Nanomaterials, the study elaborates on the synthesis of these Fe3O4 microspheres and their multifunctional properties, demonstrating their potential in targeted drug delivery and photothermal therapy. A significant finding is that the application of a magnetic field notably enhances the cellular uptake of these nanoparticles, showing a strong green fluorescent signal indicative of increased cellular uptake. Even at high concentrations, the cell viability remains high, underscoring the biocompatibility of these nanoparticles for biomedical applications. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.